Right now, above your head, there's a line you can't see and can't touch. Cross it without protection, and your body has about 15 seconds before it can't save itself. We call what's on the other side of that line space. Empty, a void, nothing. But what if that's the wrong picture entirely? What if space isn't empty at all? What if it's more like an ocean, and everything we've ever launched off this planet has just been swimming toward the surface of something much bigger than we've been told? Stay with that, we'll come back to it. First, something you can test tonight in your own bathtub. Take an empty cup, turn it upside down, push it into the water. Feel that resistance pushing back against your hand. Harder the further you push, that's trapped air fighting to stay where it is. Buoyancy. Now flip the cup right side up underwater, let it fill, and suddenly it's easy. The fight is gone. Scale that cup up to the size of a rocket, and that fight becomes a war. Which, it turns out, is a pretty good way to think about what a rocket is actually doing in the first 90 seconds of flight. Everyone knows a rocket needs a huge amount of force to get off the ground. Most people assume that force is just about gravity, lifting something the size of a building against the pull of the Earth. That's part of it. But there's a second, sneakier fight happening at the same time: air. Because air isn't nothing. Air is a fluid, just about 800 times less dense than water. A rocket punching upward through it is doing the exact same kind of fight as that cup in your bathtub, just against a much thinner, much faster moving version of water. There's a moment engineers actually have a name for max Q, the exact point, usually about a minute into flight, where the combination of speed and air density is pushing back on the rocket harder than at any other point in the entire trip. Push through that and the air keeps getting thinner and thinner until somewhere around 100 kilometers up, we draw an invisible line and call it the beginning of space. And here's where it gets interesting. Once a rocket is up there, engines cut, done fighting, the astronauts inside stop feeling their own weight. Ask almost anyone why and they'll tell you it's because there's no gravity in space. That's wrong, not slightly wrong, completely wrong. At the altitude the space station orbits, gravity is still doing about 90% of what it does down here on the surface. 90%. If gravity actually switched off up there, the station wouldn't float in orbit, it would fly off in a straight line into deep space. It stays exactly where it is because gravity never stopped pulling on it. So if it's not the absence of gravity, what is it? It's falling, constantly, continuously falling. Picture a cannonball fired so fast it never actually hits the ground, the Earth curves away underneath it just as quickly as it falls forever. That's an orbit. The station and everyone inside it is in permanent free fall around the planet. And when everything around you is falling at exactly the same rate you are, there's nothing left to push back against you. No floor pressing up on your feet, no chair pressing into your back. That absence of a push, not the absence of gravity, is what weightless actually feels like. Now here's the twist. Remember that cup in your bathtub? When it fills with water and stops fighting you, when it just hangs there, suspended, you're feeling something that, for a completely different reason, produces almost the exact same sensation. Gravity is still pulling on your body in that water exactly as hard as it always does. It hasn't gone anywhere, it's just being canceled out. Not by falling, but by the water pushing back up on you just as hard as gravity pulls down. Two totally different causes. One is falling forever and never landing. The other is being held up by a fluid. And they feel so similar that NASA built an entire facility around it. A pool bigger than an Olympic swimming pool, with a full mock-up of the space station sunk to the bottom, where astronauts train for spacewalks completely underwater. It's called the Neutral Buoyancy Lab, and it's real, and it's essentially a fake ocean, built specifically because floating in it is close enough to floating in orbit to actually matter. It's not perfect though, your inner ear can still feel down in a swimming pool because gravity's still fully there, doing its job on the fluid inside your ears, something it can't do in true freefall. Which is part of why NASA also straps astronauts into a plane that flies in giant arcs, nicknamed the Vomit Comet, for 25 real seconds of the actual thing at a time. So floating, solved twice over for two completely different reasons. But floating was never the hard part of faking space. The hard part is the emptiness, so what if you tried to fake that too? Here's the setup: take a container, hook it up to a vacuum pump, and suck every molecule of air out of it. Real machines do this constantly in labs and factories. You've made a vacuum. Now try something else. Take that same container, but instead of pumping the air out, fill it with water and strip the water of every trace of dissolved oxygen. No air, no breathable gas. Just water on paper. Doesn't that sound a lot more like space? You'd float in it. There'd be no oxygen. Isn't that basically a vacuum you can swim in? Here's where it falls apart completely. That deoxygenated water is still made of matter, about 1,000 kilograms of it per cubic meter, sitting right there in the container. Real vacuum means the matter is gone, not rearranged, gone. And space isn't just a decent vacuum, it's an almost incomprehensible one. Even the best vacuum pump in the best lab on Earth still leaves behind more molecules in every cubic centimeter than you'd find drifting through interstellar space. Water isn't a stripped-down version of a vacuum. It's about as far from a vacuum as matter gets. And it doesn't stop there. In almost every way that actually matters, water and vacuum aren't just different, they're opposites. Water pushes in on you harder the deeper you go. Vacuum pushes on you not at all. That's the two extremes of pressure, and this setup lands you on the wrong one. Water pulls heat out of your body about 25 times faster than air does. You'd be freezing before you knew it. Vacuum has no matter to conduct heat through at all. The only way it moves heat is through radiation, far slower, which, incidentally, is exactly why spacesuits still need built-in heaters and coolers, just for the opposite reason you'd expect. One more detail, almost a throwaway, except it isn't. Water is H2O, it's quite literally partly made of oxygen. Strip out the dissolved gas and you haven't removed oxygen from the room. You've just locked it up inside billions of water molecules instead of leaving it floating free as something you could breathe. So here's the honest verdict. Floating in that tank, genuinely weightless, a pool-sized stand-in for something NASA does for real. The vacuum of space, though, not even close. You'd have built something closer to its opposite. Denser instead of emptier, pressurized instead of zero pressure. Heat stealing instead of insulating. And without an outside air supply, the way you die in that tank drowning has almost nothing in common with the way unprotected vacuum exposure actually kills a person. A loss of consciousness from lack of oxygen in about 10 to 15 seconds. Not the instant freeze, not the explosion. The movies have been lying to you. Okay, so we've built a pretty convincing fake ocean. Floating, nailed it twice. Emptiness, total failure. But this whole time, we've been quietly avoiding the real question. Is there an actual surface to any of this? And if there is one, what exactly is on the other side of it? Here's a fact most people misunderstand completely. There is a hard edge to what we can ever observe of the universe. It's called the observable universe, and right now it stretches about 46.5 billion light-years out in every direction from us. Almost everyone assumes that limit is about us, that with better telescopes or better eyes or more patience, we could eventually see further. That's not it at all. Light has only had about 13.8 billion years to travel since the Big Bang. That's the whole reason. It has nothing to do with human limitation and everything to do with time. Any observer anywhere in this universe, human, alien, something we don't have a word for yet, is boxed in by the exact same wall for the exact same reason. Nothing has had time to reach anyone ever from beyond it. That's not a fog we haven't burned through yet. That's a wall built into the structure of reality itself. So, if there really is a surface, what's on the other side of it? Here's where it gets fun, because depending which answer you pick, the universe on the other side of that surface looks completely different. One version, extra dimensions. String theory, one of physics' most ambitious attempts to unify everything, only holds together mathematically if reality has 10 or 11 dimensions, not 4. Most of those extra dimensions, the theory says, are curled up so tightly we'd never notice them. But some versions of this idea propose a few of those dimensions might be much bigger than we think, and that gravity, uniquely among all the forces, might be leaking into them. Which would explain something that's bothered physicists for decades, why gravity is so absurdly weak compared to everything else. In that version, our entire universe is a kind of membrane, floating in something bigger. A surface, quite literally, with more surface than we can imagine sitting just beyond it. Another version, there isn't just one universe, there are many. And this is where people usually mash three completely different ideas into one word, multiverse, when they're not the same thing at all. One flavor comes from cosmic inflation, the leading theory for how our universe expanded in its first fraction of a second. In some versions of that theory, inflation never fully stops everywhere. It stops in some places, forming bubbles, universes like ours, while continuing forever in the space between them. Endless bubbles being born forever, most of them forever sealed off from each other. A second flavor comes from quantum mechanics itself. Every time a quantum event could go multiple ways, one interpretation says it doesn't pick one, it does all of them, each in its own separate branch of reality that splits off and never talks to the others again. It's called the many worlds interpretation, serious, respected, and has nothing to do with the bubbles. A third flavor comes from string theory again, the same one with the extra dimensions. That theory doesn't just allow one possible universe. It allows something like 10 to the 500th possible ones, each with its own version of physics, its own version of the rules. Pair that with the bubbles from inflation, and you get an almost unthinkable number of universes, each one possibly playing by different laws entirely. Worth being honest here, plenty of physicists think the bubbles and the landscape of possible universes sit right at the edge of what can ever be tested, maybe past it. That's a real argument inside physics itself about whether some of this still counts as science. Doesn't make the ideas wrong, just means hold them a little looser than the stuff we've actually measured. Some people reach for an even bigger word than multiverse, omniverse, the multiverse of multiverses, everything all at once. You won't find that word in a physics journal. It's mostly comic book language, but the hunger behind it, wanting one concept big enough to swallow every other theory whole, has a real, published cousin. A physicist's proposal that every mathematically possible structure exists as an actual universe. Every equation that could describe a coherent reality does, about as far out as physics gets. But real, and basically the closest thing that exists to what people mean when they say omniverse. And then there's a version of this that goes somewhere stranger than all of them. What if the surface isn't a wall and isn't a membrane and isn't another bubble sitting next to ours? What if it's the edge of a simulation? There's an actual argument for this made by a philosopher named Nick Bostrom, and it's not the thing people think it is. He's not claiming we're definitely in a simulation. He's laying out three options and saying at least one of them has to be true. 1. Civilizations like ours almost always destroy themselves before they get advanced enough to build a realistic simulation of their own history. 2. They get that advanced and for some reason choose never to run one. Or 3, if neither of those is true, if civilizations do reach that point and do run these simulations, they wouldn't run just one. They'd run millions, billions maybe, and if simulated minds outnumber real ones by that many, then statistically, you should assume you're one of the simulated ones. Not because it's exciting, because the math says it's more likely. Take that third door and something interesting happens to our whole ocean metaphor. Whoever's running the simulation exists somewhere else. A different reality entirely hosting ours the way water hosts a wave. That's not just past the surface. That is the surface from the other side. And here's the part that should genuinely unsettle you a little. Nothing says that outer reality isn't a simulation too. Which means there isn't necessarily one surface. There could be a whole stack of them, break through one, and you don't reach open air. You just find yourself in a deeper ocean with another surface somewhere further up, and no way of knowing which layer you're currently swimming in. So where does that leave us? Space might genuinely have a surface, not a wall you'd bump your head on, a boundary between our reality and something we currently have no way of detecting, let alone touching. And depending which theory you pick, the answer to what's on the other side changes completely. Extra dimensions were a thin slice of countless other universes birthed from an inflation that never stopped. A landscape of 10 to the 500th possible versions of physics, a totality so complete it swallows even those. Or something running the whole thing from outside, the way you're running a video right now without the video ever knowing you're there. None of these ideas rule each other out either. You could stack every one of them into a single theory, a simulated universe confined to a thin membrane floating inside one bubble of an endlessly inflating multiverse, itself one small corner of every mathematically possible reality that could ever exist. Layers all the way up, an ocean with a surface, and beyond that surface, another ocean with another surface, for about as far up as anyone has ever been able to imagine. The next time you look up at a clear night sky, you're not looking at empty space anymore. You're looking at a surface, and you have no way of knowing what or who might be floating on the other side of it, looking back down.